Here we go. So no one talk now, no one talk. Here we go. No one talk. Don't do this in the pack, make sure you do it on your notebook. Okay, as always, make sure you don't copy what I do. I can guarantee that if you're trying to copy what I do on the next test, you'll score about 48. Okay? Really, that's how it works. You've got to understand the concepts so you can apply them. So we're going to learn a couple new ideas today. So the problem starts out very familiar. It says you have a function f, and then it says find all values of x for which the graph of f is concave up. So when I read that problem, I'm reminded of other problems where they'll give me a graph, and they'll ask me to identify where f is concave up. There. The difference here is you don't have a graph. And you also don't have a calculator, so you have no easy way to create a graph. Now, if you happen to have a really, really, really good memory of previous classes, you could try and use techniques you used in those previous classes to make a graph of f. I highly recommend against that. I have not found any students ever who are good at remembering how to do those graphing techniques. So we're going to use a different method. Whenever I feel like I want to make a graph, but I can't because I don't have a calculator, I always make what's known as a Sine pattern chart. So new idea, Sine pattern chart. I've seen teachers do these in different ways, so I'll show you the way I feel is best, but I've seen other methods. Okay, Sine pattern chart. Sine pattern charts go very much with Danica's chart. So first thing, don't ever make this is where you're not just doing work, you gotta understand why you're doing it. Don't ever make a Sine pattern chart without knowing why. You have to have a reason. So first reason is I don't have a graph. So Sine pattern chart's a good substitute for a graph. You should never make a Sine pattern chart if you have a calculator, because the calculator is much better. This is just a crude substitute when you don't have a calculator. But I still have to know why I'm doing this. So I look at Danica's chart, and Danica's chart gives me the reason. So Danica's chart tells me that if I'm trying to figure out when f is concave up, I can do that by figuring out when the second derivative is positive. So this is called a Sine pattern chart because you're interested in the positive or negative. So now I have a reason why I want a Sine pattern chart. I want a Sine pattern chart of f double prime. So to create a Sine pattern chart of f double prime, I must have a formula for f double prime. Go again. Questions? Please.
Why are you doing the double prime graph?
So I'm doing the double prime graph because if I'm going to use a Sine pattern chart, I'm going to be paying attention to the sign of something, the positive or negative. And it's the positive or negative of f double prime that will tell me when f is concave up. Does that connection make sense? No, it's a good question. 2 points. No? Please.
What's from stopping us from using the f prime graph?
So with the f prime graph, you'd have to have a graph. So if you have a way to create this graph that you're confident will be accurate, that would work. But I don't. I don't remember the methods. They're too hard. So I don't like that method. 2 points. Anybody else? Cool. So I need to build a sine pattern chart of f double prime. Okay. When you go to build a sine pattern chart of f double prime, like most problems, it's best if you can do it in small pieces, not one big step. So you cannot make a sine pattern chart with these two terms. It will not work. So I can't break up f double prime into terms. It doesn't work. So don't ever do that. Don't ever try to make a sine pattern chart with these two terms of f double prime. It will not work. The reason it doesn't work is when you build the chart, you're going to be comparing like a positive value to a negative value. And if these two values are adding, just say yes or no, please. Do we know the result for certain, yes or no?
No.
Louder?
No.
No. If you're adding a positive to a negative, you don't have any idea of the result without more information. So when we build a sine pattern chart, we don't want to build the chart with terms that are adding. It doesn't work. We need more clarification on that reason why you don't do that.
Yeah, it's just.
So when we build, so I'm kind of just giving you pieces so far. But once we build the chart, we're going to be comparing positive values and negative values. If those two values are adding, like these are, if I take a positive added to a negative, can you tell me whether the result is positive or negative? No, you can't. So I don't want to do a sine chart with terms that add. It's a dead end. So I won't. Does that help?
So you'll think of it as multiplication instead?
I want to change, well, I have two options. I can do the sine chart with this as like one big factor, but that's hard because it's a big factor. It's a lot easier if I break this into smaller factors. So I'm going to do this. Sine pattern charts are another good example of if you have good notation, you will score much better on the test.
So
If you just write a bunch of crap, you're going to get way mixed up. You'll never get the right answer. Your score will be horrible.
so have we not even built the chart yet?
Not yet.
Okay.
We're just kind of heading in that direction. Like we figured out, to forgive, we figured out that we want a sine pattern chart because we can't have a graph, like Grant noticed. We figured out that we want a sine chart of f double prime because as Amanda noticed, the sine chart of f double prime will tell me when f is concave up. So that's where we're headed. We figured out that we don't really want to do this as a whole. It's too difficult, so we're going to factor. So we're going to factor out, let's see, a 60 and an x. That will leave an x squared. Subtract 2. Question?
Can you factor from there? No, wait, never mind. Choose not.
Yeah, you could. That's kind of like, I don't know. I've done it both ways.
Like if it was x squared minus 4, would you want to factor out?
Yeah, you'd probably want to factor that. Yeah, please.
How could you know to find a sine pattern chart for f double prime and how?
So if I found a sine, let's have the whole room answer this one. Points for everybody. 2 for Mario for asking. If I find a sine chart of f prime, I will figure out when f prime is positive and when f prime is negative. Just raise your hand and tell me, what information would that give you about f? What information would that give you about f? Smooth, Tyler?
Whether it's increasing or decreasing.
We know whether f is increasing or decreasing, but we don't care. We want to know when f is concave up.
Okay.
So it would give us information about f that's useful, but not for this problem. We're trying to identify this when f is concave up. So these signs don't tell me when f is concave
Okay,
up.
so sine means positive or negative.
Right,
Okay,
perfect.
so that's why you can't like do anything about increasing or decreasing.
Mhm. Perfect. So that's exactly why, 2 more from Ariel. It's exactly why this wasn't helpful. Because this is not a sine, this is like I have to have a graph to see this. But I don't have a graph.
Okay.
So I'm doing a sine chart. Yeah, sine like this kind of sine, so. Not like cosine, so yeah. Are we good? Please.
Sorry, so where it says that f is concave down, f prime is decreasing, and f double prime is negative. Well, how could it be like concave down but increasing and negative at the same time? Like, how does that work out?
So, back up one step. So we're trying to figure out when f is concave up, which means f double prime will be positive.
Bless you.
It's all good. Which means f prime will be increasing.
Yeah, but like when it's a u, there's a side it's decreasing as well, but it's still positive because it's concave up.
Slow down, slow down, slow down. Everybody look up, everybody look up. Okay, you're making a mistake. I don't want you to look close, look. Nothing on the board tells me that f is positive or negative, nothing. F double prime can be positive, but it doesn't say anything about f. All we know is we're looking for a section of f where f is concave up. Concave up and increasing would look like this. But it's not talking about that at all. It just wants to know when is f concave up. So we're not concerned with positive or negative, or does that make sense?
Sure.
I feel like I've answered your question, but
I'll ask you later.
okay. 2 for Harrison. It does factor like this. I actually think it's smart to factor like this, because a lot of students are having trouble remembering that root 2 times root 2 is what? 2. Just 2. So I think it's smart to factor to remind yourself of that fact. I also have students forgetting to factor a difference of squares, like Harrison pointed out. So that's why I think it would be best to go ahead and factor further. So, question? Cool. Okay, once we have f double prime factored, now we're going to build the sine chart for f double prime. Can I erase this stuff that's above? Okay, so let's copy this over and erase a little bit. Lord, please.
So could you just plug in numbers for x on the f double prime equation we have and find the sign that way?
It definitely is a legitimate method. It's very inefficient, and it will not, it's likely to, how should I say, on the written section of the test, you're likely to not get any points, because you'll just sit there and guess and check and just burn up time. On the multiple choice section, you might get lucky and find the right answer, but I would argue that you'll get about 1 out of 3 right, because they'll get clever on you and they'll make it so you can't do that. So even though your logic is sound, 2 points for that, I wouldn't go that way.
So when you're going from f, when you're going from f to f prime double prime, f double prime, are you finding the derivative of that original equation each time?
Mm-hmm. Well, what you're really doing is you're finding the derivative of the original equation to find f prime. That gives you a new equation. And then you find the derivative of f prime to get the f double prime. Some people like to think of it like this. You start with f, you take a derivative, you have f prime. Well, if I take the derivative of f prime, it's like I'm finding f prime prime.
Right.
We just don't write it like that. That makes sense?
Oh, yeah.
Good point.
Just
Keep clarifying. Keep doing that. We good to hear? Okay, here's how the sine chart works. A sine chart is a substitute for a graph. So I like to draw the sine chart as though it looks like I am drawing a graph. So I draw an x-axis. So the x reminds me that I'm drawing an x-axis. You want to make sure it's pretty good sized. I've seen a lot of people lose points on tests because their sine charts are too small. If you make the sine chart too small, it's hard to see the pattern you're trying to see. It's called a sine pattern chart. So give yourself some space. Okay, we want a sine pattern chart of f double prime. That's the goal. We're going to do it in pieces. And the pieces are these factors. So we're going to have a factor of 60x, a factor of x minus root 2, sorry, and a factor of x plus root 2. Building a sign chart is pretty much like building a table. You're just doing it horizontally instead of vertically. So, again, don't copy what I do. Keep asking if it doesn't make sense. You first start by figuring out which of these x values will cause this factor to equal 0. That one's easy, just 0. So the way the chart is read is I say, okay, if the x value is 0, and I plug in that x value here, what will this be? This will be 0. That's how you read the chart.
Well, all the charts we built like line. Yeah. What's the x on the right side?
It stands for x-axis.
Oh,
So this is the x-axis. And if I were literally trying to make a graph of 60x, because remember, this is the sign chart's just a crude way of graphing. I would say, hey, when x is 0, the value of this is 0.
So it's negative, then it goes negative root 2 and positive root 2, right?
Once you find the value of x, which causes the factor to equal 0, okay, you have to do that first. If you do not do that first, you're going to make mistakes. So first find what value of x. Go ahead, say it again.
will there always be value of x that makes
Not necessarily. You might not find any. It's just, so you didn't find it, that's fine. Just go to the next step. So once you find the value of x which makes this factor equal to 0, all you have to do is test two other values of x. A value of x on the left of the 0 and a value of x on the right. This 0. So come over here and you just pick any value. -1 is convenient.
Negative root 2.
So I plug in -1. 60 times -1 is a negative number. With a sign chart, you don't care about the numbers, just the positive or negative. So I know that if I plugged in -1, the result would be some negative number. The power of a sign chart is that means all of the other associated values are also negative. So I don't have to do lots and lots of computation. I can do just a quick computation, and now I know that all of these are also negative. So if I plugged in -2, the result would be negative. If I plug in -3, the result would be negative. It doesn't matter. Test once is all you do. Just one test, you're good. Question? We need to talk.
So why are we? I understand that we're able to figure out that all of them are negative beyond, like on to the left of 0 for the 60x. But what about the x minus root 2? Is that also safe to assume that if it works once on one side of x, that it'll work forever?
Mhm.
Okay.
2 points. If we need to clarify anything, we'll have it said again.
So we're going to need to do this for each of the points, not just for the 60x, right?
2 points.
So do we make like a separate sign pattern chart for like each factor?
Well, it's
Okay.
It's perfect. No, you both are doing really well. 2 points.
But so since we know that anything to the left of 0 is going to be negative, doesn't that prove that B, C, and E are all wrong?
Not necessarily. I'll show you why in a minute. Good question. 2 points. Please.
Does it matter if you write the bottom on the top or top on the bottom?
I'm not sure what you keep talking.
Like if all of the negative signs and the 0 on the bottom were at the top, and then the -1 and the 0 were
Oh, it wouldn't really matter, no. This is just how I organize it, so. 2 points. So I test over here as well. Plug in a 1. 60 times 1 is a positive number. I don't need to test for any other values of x. Questions?
Is that just regarding the 60x? Like we
Mhm.
still need to do the same?
Yep. So we're still just looking at the 60x. 2 points. So here, I picked the, oh please, Matthew.
Why do we have such a long line when we only have one value on either side of 0?
Oh, mostly my experience that unless you're really good at seeing the sign chart before you even draw it, people tend to make small sign charts and they tend to make mistakes. Big sign charts prevent the error. So that's just an experience.
Is that just so that, like, if you guess at a value that might be positive and it isn't, then you can keep going?
That, or they just get the values too close together and you can't see the pattern. Like, kind of trust me on that one for a minute. But okay, here, the x value is root 2. I do need to know, well, not really, because this -1 didn't really even matter, because they were all negative. So I'm going to erase that. So root 2 is, I don't know, here somewhere. So that's it. If the x value is root 2, this factor will equal 0. Question? The key to this is making sure you understand what you're reading, not just doing the work. So what you read is you say, if I had x has a value of root 2, and I plug that value in here, this will be 0. So now we test left and right. I just plug in 0. 0 minus root 2 would be a negative number. Questions? So they're all negative. Do not make the assumption that left is always negative, right is always positive. They love to trick you on that one. So
It's just for this column.
Go right, you can do like 2.
sure. So plug in a 2. 2 minus root 2 is a positive number, so I'm good. 2 for Jackie. Question? Please, Maria.
Where is the root 2, like, do we need to know like where that is compared to where the 1 is on 60x? Isn't that just the same thing?
Good question. All eyes up. Not really. Like, I wrote a 1 on the board to just help you understand what I was thinking. And I was thinking if I plugged in 1, this would be positive. But I don't really need to know where 1 is located. The key locations are where the zeros are located. So the 1 doesn't really matter.
So if, I don't know, I just don't want to like get confused by what I'm writing. Sort of like what you're writing.
Root 2 is definitely bigger than 1.
So I should just leave that.
So you can just leave it, it's fine. Yeah, root 2 is about 1.4. So 2 points. We do the last one. So that's negative root 2. So somewhere over here-ish, kind of. So now I plug in a value here. What I often do is I pick really easy numbers. So I just say, well, what if I plugged in negative 10? Well, negative 10 plus root 2 is definitely going to be a negative number. One test is sufficient. All the others will follow the same pattern. Good? Come over here, plug in 0 is a good test. So these are all positive. Questions? Okay, so the reason a sign chart is easy to make is because you're making the chart with really easy factors that are just mentally, you can process the data quickly. So that goes pretty fast. Now what we do is we put them together. Because what we really want is a sign chart of f double prime. Okay? There you go.
Negative is negative. Then once you get to negative square root 2, you have 0, because you have a 0 in there. And then as you like go along, in between negative square root 2 and 0, you have positive because there's only 2 negatives.
Perfect. Perfect. So the correct way to read the chart is what Jackie is doing. Now listen close to how I'm reading it. Don't just do the work. Like, I just worry a lot about that. People will watch me do it, and then when they do their homework, they lose track of what's going on and they make mistakes. The way I read this chart is, if x had a value of negative root 2, and I plug that x into here, this part of f double prime would be a negative number. This part of f double prime would also be a negative number. Those two negatives would multiply. Negative times negative is positive. this part of f double prime would be 0. So all three would multiply. That's what we're doing this way. We're saying this part's negative, this part is also negative, this factor would be 0. So negative times 0 is 0. So I'm just figuring out what f double prime's value is for lots of different values of x. That's all I'm doing.
So put to the left is 0, on the bottom you can write negative, right?
Perfect. Because over here, like say at x equal negative 10, if you plug in a negative 10 here, here, and here, the chart is telling you what happens. They're all negatives. So when they multiply together, the result is negative. That's why you can't do a sign chart with things that are adding.
And that's why you want to keep them farther apart.
So when you want to get them apart so you can see the pattern of what's happening. It's all scrunched together, you can't keep track of it.
Is there any way you could just rephrase the last little bit? Just
I'll get you to say it, it will stick better. So what we're really trying to do is we want to know when x is negative 10, what is f double prime? Is it a negative number or is it a positive number? The way we figure that out is we say, when x is negative 10, this factor of f double prime, is that a positive or negative? Yeah, we figured that out already, we wrote it down. How about this factor? So when you take negative times negative, you get good. But this factor would be as listed. So really we have negative times negative times negative, which is negative. So when x is negative 10, f double prime is definitely some negative number. Is that your question?
yeah. So you're not logic. You're not using logic like 60 times negative 10 is negative. You're looking at the chart to help determine that.
What I'm doing is I first figured out for all these different x values what's happening to this all by itself. And then I wrote it down.
Okay.
Then I did the same for these two. Now I'm going back and I'm doing everything simultaneously. But because I have good notes, it's easy to remember. So I come here to x equals 0. You should always do the zeros first, by the way. They're the key locations. So when x equals 0, this factor will be, it says right there, 0. This factor will be what, Gil?
Negative.
This factor will be?
Positive.
Right, because we wrote it down. So now we put them together. We say at x equals 0, these three values multiply to give a result of 0. But right here, like between, in this location, for this value of x, this factor is negative, this factor is negative as well, but this factor is positive. So when those three factors multiply, the result is louder?
Positive.
Louder?
Positive.
Any doubts? Please.
Would it be wrong to think of those three numbers as limits in the equation?
I don't see a connection with limits. They're not really limiting values. They're the actual values. We just don't know the numeric value. So we know that when x is negative 1, this factor is negative. This factor is also negative. This factor is positive. But I don't know positive or negative, so I wouldn't connect it to limit. 2.8.
So then, are we taking all the f prime values of the negative 0 or positive to find the concavity of that?
Perfect.
Is that like
That's
so?
exactly what we're doing.
So we're not even the number that we're not plugging in for negative 10 or anything. That's not important, right? It's just that getting numbers down so you have something to look at.
It's all about we're just building a graph. But the graph we're building has no numbers on it. It only has positives and negatives. So it's a lot faster to build the graph because the computations are much quicker in our head. But that's all we're doing. Two more? Please.
Sorry.
No, keep talking.
So then, could you just look at the graph without plugging in numbers? You can just kind of look at, okay, at the far left there's 3 negatives. So that's a negative.
You have to plug in, I teach you to test, because on something like this, it's pretty easy to see without thinking of hardly any numbers at all. But on something more difficult, it's hard without thinking of some numbers. So that's why I'm saying we can test. So. Point? Anybody else? Cool. So you go here next. At x equal root 2, the first factor is positive. The second factor is 0. The third factor is also positive. Multiplied together, the result is 0. Okay, back to left room. To answer his question. He said, why don't we make this smaller? Here's the mistake most people make. They make the chart so small that once they find these zeros here, the zeros are so close together they forget that there are numbers still in between. Like it's not possible on the sine charts we'll do to ever have 0 with nothing in between. So you've got to leave space to figure out what's happening in between. And unless, again, you can see the whole problem in your head, the easiest thing to do is just don't make it so small. You don't have some room to work. So, cool. This is positive. Negative. Oh, wait a minute. Yeah, negative. My bad. This is negative. This is positive. So again, the way the chart is read is you would say, way over here, at x equal negative 10, or x equal negative 100, or x equal negative 1,000, whatever, the value of f double prime is negative. So if you had a graph of f in front of you, and you were looking at the graph of f, like this, if you were looking at the graph of f way over here, would you expect to see a graph of f that has a concave up shape or a concave down shape? Concave down. So you can make a note of that if you want. So here f is concave down. Here f is concave up. Like that. So we're looking for concave up, so we're between negative root 2 and 0.
What are the 3 dots? Just like,
Oh, that's just a dashed line. You can draw a solid line, doesn't matter. I'm just showing you the divisions. So. Question. If the idea makes sense to you, it's really a very simple idea. Like I just can't get a graph of f, so I do a chart of f double prime instead. But I build the chart very much like I would build a table.
So, if the question was asking like find all the values for which f is increasing, you just do the same thing, but just for f.
Perfect. This is what you just said. If the question had asked, figure out for what values of x is the graph of f increasing, I still can't do a graph, so I want to do a chart, but I want to do a chart of f prime. Otherwise, the technique is identical. Matthew?
Would this work when it's asking for an in between, like with a maximum or a minimum?
So we're going to do that kind of a problem next, but you are absolutely correct. If you have to figure out where f has a relative max or relative min, and you do not have a graph available to you, no calculator, I'm going to use a sine chart. Absolutely. F prime sine chart. Don't ever make a sine chart unless you understand why you are making it. Otherwise, you're just doing steps. It's not going to help. You're just wasting time.
What if you only have 2 factors instead of 3?
There'll just be 2 rows instead of 3. Some problems will only have 1 row. Like there's no way to break up what you're trying to chart. Please.
If you're looking for when graph of f has like a relative maximum or a relative minimum, would you use the sine pattern chart for f prime or f prime?
Good question. Everybody look at the board, 2 for Emma, 2 for Grant. Okay, if you go back to the white reference sheet, the white reference sheet says f has a relative max when f changes, increase to decrease. You do not want to involve concavity when finding a relative max. It tends to cause errors. So I would make a sine chart of f1. Question? Awesome, perfect. Stop this one, let's do a different one.